Hello students, welcome to class 11 Mathematics. Here we go for the unit 1 sets and functions. So under that we have the first chapter, sets. When we think about the set, many wonderful things will come within our mind. If girls are there, they'll have in the mind about set of jewelry, right? And if it is boys, cricket kit, right? So when we say set of a jewelry, they are all related to each other, right? They belong to the same category. Same way, if you go for the cricket kit, see those, whatever it is there in that kit, it is related to the cricket, right? Okay, so let's go for a simple example. See, here I've shown you some simple examples. This is all geometric figures, right? 2D figures. So can we say closed figures? So set of polygons. What it is? Set of polygons. This is beads, right? So set of beads. So they all belong to same category, right? This is 2D figures. They come under same category, set of polygons. And here, what is this? Set of tools. Set of water bottles. And this is set of a jewelry, right? So all they are examples of sets which we observe in real life. Correct. Let us move on to the main concept. So here we say set is a well-defined collection of objects. Why well-defined? Because in specific we have the objects in a set, right? See, in the previous example we checked out set of tools. So all they are what they belong in the same category. So we call it well-defined. Then we saw a set of polygons where all they belong to the same category. All they were geometric figures, right? Okay. Set is represented by capital letters A to Z. So you can prefer any letters between A to Z. Here's one simple example. A equal to set of all vowels in English alphabets. Actually this curly brackets, you call it braces or brackets. This curly bracket means set of all. Set of all, yes. So vowels in English alphabets. So all are aware, you have been learning in your junior classes A, E, I, O, U, right? So here, how do we say it? A is a set of all vowels in English alphabets. So mathematically, if you are writing, you will write A equal to A, E, I, O, U within curly brackets, and each letters are separated by commas, right? See, in your set, this is the name given to your set A, and this A, E, I, O, U is nothing else. It is elements, or you call it object, or you call it member of the set. So each term, either you call it object, member, or element. Next, I, some different symbol we can see. What is this? It is a Greek letter epsilon. Okay. So here mathematically epsilon belongs to, and when you strike that epsilon, it says does not belongs to. Let's see. So here we can say, read it as I belongs to A. Is it true? Yes, I belongs to the set A, right? This A represents the set which contains the elements A, E, I, O, U, and here they are telling I belongs to A, but B does not belongs to A. True, in our set A we don't have B. So we can say B does not belongs to A. So I hope this is clear. It is a very simple concept for you to understand sets. See, set is the base of most of your chapters. You learn, when you learn how this set concept, then for you the other chapters will also be easy. Even for your trigonometry also you need some base of set. Okay, let us move on. So terms in set is called as object, element, member. As I have told you also, A, E, I, O, U are objects, or you call it element or member of the set. So sets used in mathematics. Usually the sets which you have used in your junior classes and you have learned also. When it is capital letter N, what do you call it? Where did you see this? Yes, set of all natural numbers. I need not tell you what are these natural numbers. It starts from 1, 2 and so on. Okay. Then we have Z, which represents set of all integers. Integers means negative numbers as well as positive numbers and including 0. Next, set of all rational numbers. Rational number is nothing, it means actually a fraction. Fraction means not only 1 by 2 is a fraction, it's like you learnt in your junior class p by q. So 1 by 2, fine. But if I say 2 is a number, is it rational? Yes, it is a rational because you can represent 2 as 2 by 1 in the form of fraction you can represent, that is p by q form you can represent. So 2 is also a rational number. We know that in rational number what all is included? Natural number, whole number, as well as integers are included. Along with that, fractions are included. Is it clear? Okay. Real number is very simple. It means family of all numbers. It includes everything. Your natural number, whole number, integers, then irrational number, rational, everything it holds. The set holds everything. So we can call real numbers, set of real numbers, as family of numbers. Next, z plus. It is nothing, set of positive integers. So it starts from 0 actually. Okay. So it starts from 0. It will exclude negative numbers. Set of positive rational numbers. So all positive rational numbers will be included. And this is set of positive real numbers. I hope this concept is very clear and very simple, which you have done in your junior classes. Okay, now what we have learned related to that, we have some problems in exercise 1.1. So we'll go for the first problem. Which of the following are sets? Justify your answer. The collection of all months of a year beginning with letter J. We know that there are 12 months in a year. Yes. So there are 12 months in a year. So it is a collection of months in a year. Fine. But what they are saying is, here we have a condition, it is beginning with the letter J. So January, June and July are the months beginning with the letter J. So this collection is well defined, right? It is in specific, the month which begins with J. Hence it is a set. Fine. Did you all understand how do we call it a set? Like I have told in the previous some real life examples I have told. So like when a object, when it belongs to the same category, you call it well defined. So that time you can say like it is a set. Okay, next problem, next question. The collection of 10 most talented writers of India. We have many talented writers in India. Harivansh Rai Bachchan, Prem Chand, Durjoy Datta, Chetan Bhagat. These are all examples of most talented writers in India. So let's see, can you tell in specific who would be the most talented writers, like the most talented, the best 10 one? It's quite difficult, right? So there are many talented writers in India. We can write the way of answering, okay? So in specific, we cannot form collection of 10 most talented writers, right? So hence it is not a set. Next, a team of 11 best cricket batsmen of the world. We have many best cricket batsmen, right? So again, we can see that there are many best cricket batsmen in the world. So in specific, we cannot form a team of 11 best cricketer batsmen of the world. It will vary from one person to another person. The best players will be differing. It won't be same always. Some may prefer Dhoni, some may prefer Kohli. So some may prefer Shane Warne. So it may differ from individual to individual, right? So hence it is not a set. Next, the collection of all boys in your class. It's obvious we have a fixed number of boys in the class. So it is collection of boys in the class, a well-defined collection. Hence it is a set. Next problem, the collection of all natural numbers less than 10. So we know the natural numbers 1, 2, 3 and less than, it was 100, right? So less than 100. So less than 100, that means we are not including 100. It is less than 100, not less than equal to 100. So less than 100 is 99. So from 1 to 99 we have these numbers, right? So these are collection of numbers less than 100, which is well defined and is well defined. Hence it is a set. I'll go for one more problem. I think it's quite easy, right? So one more problem I'll go and I'll move on to the next question. A collection of novels written by writer Munshi Premchand. Okay. So Munshi Premchand's collections, obviously the whatever novels he'll be writing, it will be in specific, right? It will be a well defined one. whatever he's writing, he'll be aware, even people will be aware. So without anyone's awareness, nothing will be written out of the category, right? So none of his novel will go out of category. Like he has written a novel, it will come under his name. If he has not written, it won't come under his name. So collection of novels written by writer Munshi Premchand is well defined. Hence it is a set. Okay. Second problem, let A equal to 2, 3, 4, 5, 6, 7. So here we have 6 elements in set A. Insert the correct symbol belongs to, does not belongs to inside the given spaces below. First question, it was 5-A. So it's nothing. 5, yes, it belongs to A. Next, 8. 8 is there in the set? No. So we say it does not belongs to A. Third question, 0, does it belongs to A? No. So this type of problem, easy, right? So we have next topic, representation of sets. Sets can be represented in two methods. That is, one is roster form and the other one is set builder form. You may interchange the names for convenience. I'll tell, like, you just try to remember any one properly and the other one will be the contrast, that is ulta of that. So if you prefer roster, you can remember that how exactly it is. It is set builder. I'll tell you, in roster form it is a tabular form, that is you write the elements in specific. But in case of set builder form, you write in statement form. How do you write? In statement form. When I explain, you'll understand more. So let us move on to roster form. All the elements of a set are listed. It is in the form of list. The elements are being separated by commas and are enclosed within braces, that is curly brackets. So we'll take an example, set of odd numbers less than 10. So all the elements are listed, right? So it is in the form of list. See, it is listed. So what is the condition less than 10? So we know the odd numbers, right? From where it begins, 1, 3, 5, 7, 9, right? Okay, I should have given set of odd natural numbers, then it would have been more clear. Okay, so here find separated by commas, enclosed within curly bracket. In roster form, an element is not generally repeated. You don't repeat an element. All elements are taken as distinct. That is in specific. Okay, set of letters forming Mississippi. See, I'm forming the set. Okay, M, I have written M. Then I have written I. Then I have S, I have written S. But again S is repeated, so I skip it. Again I is there, so I skip it. Again S, I skip. Again S, skip. I skip. We have P, so I write P. But here again it is there, so I skip. I skip. So this is my set for the word Mississippi. I hope this is clear to you all. Set builder form. As I have said, it is, you write in a form of statement. Let's see how do we write. All the elements of a set possess a single common property which is not possessed by any element outside the set. Okay, set of odd natural numbers less than 10. So how do we represent? Obviously we'll have curly brackets and you will have a letter to represent the set. So A equal to curly bracket X such that X. Always you begin with this form for set builder form. Okay, and this colon you call it such that. Each element inside your set is represented by small letters. That is, I can say this is X1, then X2, this is X3, X4, X5. Each element is represented. That is, you can say X1 equal to 1, X2 equal to 3, X3 is equal to 5, X4 is equal to 7, X5 is equal to 9. Okay, now next, X such that X is a odd natural number. So you write it from the question itself. Odd natural number. And what is the condition? That element is less than 10. That element, whatever it belongs to, the set is less than 10. So what letter did we use to represent the element X? Individually you will say X1, X2, X3 in specific. Okay, so X less than 10. Fine. Oh, it is read as set of all x such that x is an odd natural number and x is less than 10. We'll have an example. A equal to x such that x is a natural number which divides 42. Can we try to write an roster form? Let's try to write. Okay, we have 42, right? To know which one number divides 42, we'll try to find its factor. We'll start. First, we'll go for 1 into 42. So, 1 into 42 is 42, right? So, 42 ones is 42. Next, 2 will check. Yes, it is divisible. So, 42 twos is, not 42 twos that is 21 twos 21 into 2, right? Is it divisible by 3? To check the divisibility in 3, what do? We add the digits. 4 plus 2, 6. Yes, 6 is divisible by 3. So, obviously 42 is divisible by 3. So, 3. So, how many times? 14 times. 14 into 3. Fine. Okay, next we'll go for 4. 4, it is not divisible. 5 also not. 6. Yes, 6. How many times? 7 times. That is 6 sevens are 42. Is it clear? Now after 6, what do we have? 7. 7 is already there. Then 8, no. 9, no. 10, no. 11, no. So these are the numbers. These are the factors which are divisible by, which divides 42. That is 42 by 1, 42. 42 by 42 is 1. Divisible, right? So you got it. So this is also one way to find the factors while checking its multiples. Okay. So what do we have in the roster form? As we know, we write roster form in the form of list. Name won't change. You can keep the name as it is. So what are the numbers? 1, 2, 3. We'll write in order, okay? Otherwise, like, if no issue, you can change the order also, no problem. It won't affect the property of your roster form. Well, I'm writing in order, so it looks bit better. Okay, 14. Then we have 21. Then at last we have 42. I hope this is clear. Okay, fine. Next we have this. I have explained you all how to convert your rows, like your set builder to roster form, because you will be having an exercise. Your next example is b equal to y such that y is a prime factor of 42. Prime factor of 42. So obviously we have 42 here. So which are the prime factors? Prime factors, yeah, quite easy, right? If you know the prime number, so it's easy. Otherwise you have to search for it. Think about it. I guess all know because you're in 11th class 11, so all should be aware what are the prime numbers. It will have the factor, the number itself, and 1. So we have 2, 3 and 7. So we'll write. So set contains 3 elements, that is 2, 3 and 7. I hope this was quite easy. See, converting from set builder to roster is easy, but when you convert the vice versa, a bit you'll get confused. You may commit mistake, but let's see how to avoid those mistakes. So let's move to the exercise question. The continuation of exercise 1.1, third question. Write the following sets in roster form, that is in the form of list. A equal to x such that x is an integer and minus 3 less than equal to x less than 7. Less than 7. Okay. So when we start, please do write the given. Then integer. What does elements represent is in the form of integers. So we know these are all integers, like dot dot, minus 5, minus 4, minus 3, minus 1, minus 0, 1, 2, 3 and so on. But what is a condition? What all numbers are included? The numbers between minus 3, why? Because here equal to is there, so we include minus 3. But we can't include 7, why? Equal to is not there. So which number is less than 7? 6. So what all will be taking? Minus 3 to this 6. Sorry for including this, I'm just avoiding it. Sorry. Okay, so here we have minus 3, minus 2, minus 1, 0, 1, 2, 3, 5, 6. So this is our set in the roster form. I hope this is clear. Okay, so here other sub questions are there. It's quite easy. So I'll go for the fourth question. Write the following sets in a set builder form. You have 3, 6, 9, 12. Can anyone tell in what form his numbers are? Yeah, it is multiples of 3. That is, we write the given once again. That is 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. So what is varying here? 1, 2, 3, 4, right? Under what does this number comes? This number comes under natural number, right? So what is the condition? The number should be less than equal to 4, 1 less than, the numbers between 1 and 4, right? So can we say it is 3 into 1 here? Yes, why? The number is changing, right? So to represent that changing number, we use a variable n, and we know that n belongs to natural number. Did you all understand why did I write n belongs to natural number? The reason is nothing, because 1, 2, 3, the number which is changing, it belongs to the set natural number. So in the beginning, when I started with the set, it was followed with sets which were related in mathematics, which you have learned in your junior class. I just revised once again so that you're familiar with it. So how do we continue? A equal to, don't forget, always write this thing in the beginning only. X such that x equal to 3n, that is 3 into n, where n belongs to n, and the condition is the values which it lies between 1 and 4. But what did I write? 1 less than equal to n less than 5. If I would have written here equal to, then I could have written here 4. Okay, no issues. If you prefer to write in this way, no problem, or you write less than 5. So here we complete one question where we have converted roster to set builder form. Next question. 2, 4, 8, 16, 32. See, many numbers will be given. You should understand the form, what it is. Okay, so in what way it is 2, 4, 8, 16, 32? Yeah, it is in the form of 2's power. 2 raised to 1, 2 square, 2 cube, 2 raised to 4, 2 raised to 5. Here we have. Is it clear? So what is varying here? Again 1, 2, 3, 4. That is varying. For that, representing that, we use a variable, right? That is 2 raised to n. And what over n? We know that it belongs to natural number. So, okay. So y is to y such that y equal to 2 raised to n, where n belongs to n, and 1 less than equal to y less than equal to 5. Is it okay? I hope till here fine. Okay. Next, fifth question. List all the elements of the following set. Let's see what we can do here. First question. A equal to x such that x is an odd natural number. Okay. So listing means writing in the roster form. So 1, 2, 3, 5, 7. All it goes on and on. And like it's not stopping. So here one name we can give. Does it stop? No. So we can say it is a infinite set. It goes to infinity. Does not stop. On and on and on. If it stops, then you can say finite set. Okay. Second question, sub question. B equal to x such that x is an integer minus half less than x less than 9 by 2. So we write the question once again, that is given once again, and we'll check our condition. Minus half less than x less than 9 by 2. So what they have asked to list out integers which lies between these numbers. So we'll write in the form of decimal. Okay, if you want, you can write, for more clarity I have written actually, that is minus 0.5 less than x less than 4.5. okay, so we know the number which lies between this is 0, 1, 2, 3, 4. So in the list form, b equal to 0, 1, 2, 3, 4. Here we'll go through one example. Okay, match each of the set on the left described in roster form with the same set on the right described in set builder form. Let's see. We have P, R, I, N, C, A, L. What do you think it belongs to? To what does it match? It does not match to this one. Not even this C, D. Why it matches to this one? X such that X is a letter of the word principal. Let us form this set. So what we'll get? It will include P, R, I, N, C. It won't include this IY, it's already there. Then we have P again, so it won't repeat, we won't be repeating it. Then we have A, L. Same elements are there, right? So it matches to D. Okay. Now next, 0. What do you think? Which set? Which one will match? This one, C. Why? See, X such that X is an integer and X plus 1 equal to 1. What will happen? X plus 1 equal to 1. When you solve this, what will happen? X equal to 1 minus 1. So obviously it's 0. Okay. So our set will contain 0. So it matches C. Next we have 1, 2, 3, 6, 9, 18. We are done with this. We have done with this one also. So 2 are remaining. So what do you think, to what it will belong? Yeah. First one we'll check. X such that X is a positive integer and is a divisor of 18. Factors of 18. Let's check third one. 1 into 18. Yes. 2 into 9. 3 into 6. Any other numbers will be divisible by 18? I don't think so. So third one matches with A. So obviously the remaining one is the fourth and B. It matches, but you should know why it is matching. Here we have x square equal to minus 9 equal to 0. So can we write x square equal to 9? So when we take square root both the side, what we'll get? X equal to, that is root of x square is x and root of 9 is plus minus 3. So we have two values for x, that is plus 3 and minus 3. The same thing is here, 3 and minus 3.